Hi, this is exponent rules, multiplying and dividing with exponents. So with this warm-up, any base, so when I talk about base, that's the number that, or the variable that is raised to the power. So anything to the 0 power is 1. And we can get into that later on how that actually works out. Any base to the first power is itself. That means it is multiplied by it's not multiplied, there's only one of them. And number 3, 4 to the third. An exponent is the simplified version of multiplication. That means 4 times 4 times 4, and that is 64. Now a negative exponent, we actually treat this different. You take the base and the exponent, and you're going to make it into a fraction, into the denominator. And it becomes a positive exponent. So 4 to the negative 3 is the same thing as 1 over 4 to the positive 3. So we change the exponent, and 4 to the third is 64. All right, let's look into these notes. How can we rewrite x to the fifth without using exponents? X to the fifth, if you take a look back at number 3, the exponent means the base times however many the exponent is. So it's the same thing as x times x times x, so 3, 4, 5 x's. So 5 x's multiplied together is the same thing as x to the fifth. So now we're going to take that same concept and we're going to multiply. We're going to work out this problem over here. The 12x to the fifth, y to the second times 4x to the seventh, y to the sixth times z. There's a tiny little dot here in the middle for multiplication, but really in between each individual part here, constant and variable, there's multiplication. So there's multiplication throughout the whole problem. We just don't typically write all of the the dots. So when we're multiplying these out, step number 1 is to multiply the coefficients. And you might be saying, Mr. Johnson, what are coefficients? So I'm going to highlight this in green, and I'm going to show you what the coefficients are. So the coefficients are the numbers. So you're going to multiply those. So 12 times 4, that's 48. So I'll keep the highlighting going with this. Next, you're going to write out all the variables. So let's do this in a different color. So we're going to write out the variables using exponent, or from the exponents. So like x to the fifth is going to end up being x times x times x times x times x, so 5 x's. That's x to the fifth. X to the seventh is 7 x's. So we're going to keep going. 1, 2, 3, 4, 5, 6, 7. So that's 7 x's. When you multiply those all together, how many x's do you have total? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 x's, so that's really going to be x to the 12th. What else do we have here? We have a y's. So we have y squared So we have y squared. Well, y squared is y times y. And we have y to the sixth. So that's 6 y's multiplied together. 1, 2, 3, 4, 5, 6. How many is that total? We have 1, 2, 3, 4, 5, 6, 7, 8. So if we want to count these, there's 1, 2, 3, 4, 5, 6, 7, 8. So that is y to the 8th. And then we have one more z that is by itself. That's going to be just come down as z. And you could say it's to the first power if you'd like, but you don't need the 1 there. And that is your final answer. So we're going to add, so after we write out the variables, we count each variable. And those are going to become your exponents, whatever you count them as. And then lastly, you have to, the last thing is to write out your answer. Now, if you want to take a look back, I don't expect you to write these out every single time. If you look at the original problem, or let's look down at the bottom. There's actual rule. There's no way mathematicians do this every single time. You certainly could, but there's no way that they're going to do that. So there's an actual rule for this. So let's take a look at number 1. So the rule is you're going to add exponents with like bases. And in this case, the letter. So let's look at number 1. We have like bases, both are x's, they're being multiplied. So with like bases, with multiplication, you add exponents. All right, you could take x, 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 so 3 x's and then 5 x's. You could add them together. Not add them together, I don't want to do that. There'd be 8 x's total, so that's x to the 8th. Same thing as you just take your exponents here and do 3 plus 5, and that's x to the 8th. That's your final answer. All right, number 2. We have coefficients, so make sure you multiply that. That's the first step. So 3 times 7 is 21. And then let's check to see if we have like bases. We do. We have y's. So with like bases, with multiplication, we are going to be adding the exponents. So 9 plus 4 is 13. So it's y to the 13th. All right, number 3. That's crazy. We need to multiply our coefficients, so 6 times negative 2 times 2. And that is negative 24. We have x to the 3rd times x to the 0 times x to the 4th. And that's it. So 3 plus 0 plus 4 is 7. So that's x to the 7th. Then we have y to the 9th, y to the 2nd, y. And you think, well, what is that y really to? It's y to the sort of the first power. When there's not an exponent there, it's always to the first power. So we have 9 plus 2 plus 1 with the y's, so that is 12. So that's going to be y to the 12th. And then looks like we have z's left. So we have a z squared, z to the 5th. Like bases. So we have z to the 2 plus 5 is 7. And there you go, that's the simplified. All right, now we have distributing. We did this earlier this year. We have a monomial, 5x squared y. That's a monomial. There's no addition or subtraction with it, so it's all just one term. And we're going to multiply it by this binomial. There's 2 terms here. So first we multiply it 5x squared y times 3xyz. What are we going to get? So we got to multiply the coefficients. So 5 times 3 is 15. We need to multiply, get our like bases together. X squared and x Remember that x is to the first power, so that's x to the third. We have y times y. Those are those exponents, 1, which is y squared. And then a z comes along. We now have to multiply 5x squared y, distribute it to 2xy squared. I'm going to bring that subtraction down. You could have brought it with the 2. We have 5, so this is minus. So we have 5x squared y times 2xy squared. So 5 times 2 is 10. X squared times x to the first is x to the third. Like bases, add exponents. Y to the first times y squared is y to the third. And then that's it. All right, now we're going to be doing double distribution with exponents with distributing and double distributing. All right, we have two different methods of doing this. So double distribution is you have 3x plus 4, 2x minus 7. I'm going to do this with some highlighting here. So you have the 3x, and that's going to be multiplied times 2x. 3x times 2x, that's going to be like, so multiply the coefficients, so 6. X times x is x squared. So that's the 3 times 2x. Then we have to distribute that 3x times negative 7. So 3x times negative 7, so it'll be a negative, so you could do it a plus 3x times negative 7, and that becomes a negative 21x. 3 times negative 7 is negative 21, and the x comes along. So I distributed the 3x to the 2x and the negative 7. Now I'm going to have to distribute the 4. What's another color I have here? Oh, that's the same color. The 4 has to be now distributed to the 2x. So we're going to add 4 times 2x is 8. 4 times 2 is 8. And the x comes along. And the 4 times the negative 7. So plus 4 times negative 7 is a negative 28. So I'm going to write minus 28 instead of plus a negative. Once you do this, now you have everything's multiplied. Now we look to simplify. Like terms, we have our like terms are in the middle here. We have 6x squared. The negative 21x, we have negative 21x's. The x's are telling us those are like terms. The reason why x squared is not is because you have the square. That is its own term. You need, that's saying you have 6x squareds. Now we are subtracting 21x's. So you're just counting. We have a negative 21x's, and we're adding 8x's. That's going to be a negative 13x minus 28. And there's your final answer. So that's double distribution. You can do it that way. Here's the box method. Box method, we have a binomial times a binomial. Binomial means 2. So we're going to make a box with 2 columns, and each column is going to have, so we have 3x and then plus 4, and we're going to have 2 rows, so 2x minus 7. It does not matter which binomial you put where. The 3x minus 4 could be on the left, and 2x minus 7 can be on top. Now, when you multiply this out, we do 2x times 3x, and that's going to be 6x squared. Then we have 2x times 4 is 8x, a positive 8x. So I write plus there. we have a negative 7 times 3x ends up being negative 21x. And in the end, we have negative 7. I don't have any of the other colors. Negative 7 times 4 is negative 28. When you multiply them out, you have to look for like terms. A lot of times your like terms are these diagonals. You'll see in the top left you have 6x squared. There's no other x squared terms, so that comes down. Negative 21x minus or plus 8x is a negative 13. Negative 21 plus 8 is negative 13x. And then we have a subtract 28. So you can see, either way gives you the same answer. One is a little organized way and with a box, and the other one's double distribution. You are more than welcome to work on either one. I'm going to do the box method. So I have x plus 4, x minus 3, multiply x times x is x squared, 4 times x is 4x, x times negative 3 is negative 3x, negative 3 times 4 is negative 12. Look at your like terms. Top left is x squared. We have negative 3x, and you're adding 4x. So if I owe someone 3 and I give them their money back, I have 1x left. So it's plus 1x or just x. And then minus 12 in the bottom right. You don't need the 1 there. 1 times x is x. So this would be your best answer. I'll do the double distribution way on the number 6. Again, it does not matter which way you work this out. But we do 2x times 2x is 4x squared. 2x times negative 5 is negative 10x. 5 times 2x is 10x. 5 times negative 5 is a negative 25. Look at your like terms. A lot of times you do all multiply in that order. The middle terms will be the like terms. You have 4x squareds. There's no other x squared terms. You have negative 10x plus 10x. Those will actually simplify to 0. And then so you have a subtract 25 left. And there you go. There's your final answer.